you everyone for joining today. My name is Andrew Gludt. I am the Director of Partnerships and Business Development here at Neuton.AI. We're super stoked to have all of you join us for this discussion around the TinyML Cookbook. I'm already getting hungry. But yeah, we will kind of look at the motivation behind Gian Marco's reason for developing the book, as well as kind of dispelling some of the myths around the need to necessarily have, embedded engineering experience to be able to actually deploy TinyML on the edge. So for today, the agenda, we will be going over the book with Gian Marco, and then we will have a quick practical use case of one of the recipes from the cookbook, which we will take a look at how we can build one of these models with the Neuton platform. And then we will end it off with some information regarding Arduino Pro family, their ecosystem, as well as their community. And as Yulia mentioned, please stick around till the end. We will be doing a book giveaway. So we'll get you all the information you need to be eligible for that as well. If you have any general comments or anything like that, feel free to drop it in the chat. If you have any questions, feel free to drop it in the Q&A session. We'll make sure we address those as we go through the session. And so just ways of introductions. Thank you, Gian Marco, for joining us today. We're extremely excited. Gian Marco is a team lead and tech lead in the machining group at ARM, and who also co-created the ARM Compute Library in 2017. The ARM Compute Library is currently the most performant library for ML in ARM and is deployed in millions of devices worldwide, from servers to smartphones. So thank you so much, Gian Marco, for joining us today, and feel free to take it away.
That's great. Thanks a lot, Andrew, for this introduction, and welcome everyone. So I'm really excited to be here to present a book that I hope it can be beneficial for people to enter the world of TinyML through practical examples, but also super excited because this morning I got a nice surprise. I got my paperback copy just in time, I would say. So it's really, really cool to touch it, to see the book. So let me share my screen. So let me share the screen. So
you can go on. Mm-hmm.
That's perfect. Play from the start. Can you see my screen?
Yes.
That's perfect. So, okay, so today I'm here to talk about TinyML Cookbook. So the book that I wrote in last year, so in 6 months, more or less, which is a practical book that wants to help people to enter the TinyML world through practical examples. Is not just a book that wants to explain how to do the things. This is a book that definitely explains how to do things, but also explain the why we do the things in this way. The book is available in pre-order on different platforms such as Amazon, but from the 1st of April will be officially released. So let's start. And as Andrew said before, the agenda is more like this. So I'm gonna explain why I decided to write the book. So the book motivation. After that, I will jump to the book structure. And in this section, I'm gonna talk about the chapters of the book, explaining and presenting what the reader will learn and do in each chapter. And after that, we will have a practical session where I'm gonna show one chapter of the book, chapter number 3, where the project is a smart weather station for forecasting the snow. And after that, Neuton.AI will follow up with another practical session, because they read the book, but also extended chapter 3 for forecasting not just the snow, but also the rain. So they extended the chapter 3 for making it even more smarter. So let's start from the first part, the motivation. And I don't want to start straight to saying, oh, I wrote this book, because I want to start giving the explaining what TinyML is, because this book is about TinyML, but also because from the TinyML definition, I can also explain why I decided to write this book. So the definition you can find here is more or less what you can find on the internet and other places. Is a fast-growing field at the intersection of machine learning and embedded systems to enable smart applications on extremely low-power devices. So as you can see here, there are three important words, three keywords. So machine learning, embedded system, and low-power devices. These are the ingredients that can unlock TinyML applications. So in the context of the TinyML Cookbook, machine learning is actually deep learning and will be used indistinctly. Embedded system or embedded device will be a microcontroller. And in terms of low power, since we are going to use microcontrollers, we are talking about milliwatt or below in terms of power per consumption. These are the concept you will find, or the ingredients that you will have in the TinyML Cookbook. However, apart from the three keywords, there is also another one underlined, which is intersection. So why I decided to write intersection, to underline intersection? The reason is simple. It's simple because in TinyML, machine learning and embedded system must know each other at best. We cannot have TinyML applications if the machine learning model does not know the target device. On the other way, the embedded system must know the machine learning algorithms to expand the computational capabilities of this device and making the device even more performant from an energy and computational point of view. And how can I explain this? So in these years at TAM, I have been lucky enough to work on machine learning since from the very beginning of my career in the company. I have been working on the server space, on the smartphone space, and also microcontrollers. But what we have on microcontrollers is completely different from what we have, for instance, on a server or on a smartphone device. And here probably I can use an example, because in 2014, 15, we at TAM, we were already deploying some machine learning algorithms on the smartphone. And what was the main challenge there? Well, it wasn't the deployment itself, it was about performance, because we had a model trained on a server that we wanted to deploy on the smartphone, but of course we needed to make it extremely efficient. So the problem was around just performance. So making the machine learning algorithms really efficient from a computational perspective. However, when we touched the microcontroller world, it was completely different. It wasn't just a problem of performance, it was also a problem of memory, because the device we are having in front of us are devices just with few kilobytes of RAM and probably some few megabytes of program memory. So are really tiny and memory constrained devices. That is the reason is intersection. However, to explain the motivation, I need to highlight another word, which is two words actually, growing field. The question is, since when? And here I don't want to answer saying, oh, the first machine learning application microcontroller was that year. Here I want to use my experience. When was for me the first time I heard about machine learning on microcontrollers? And it was in 2013. It was at uni. It was during the course of ambient intelligence at the University of Pisa. The first slide of that course was, if words could talk. Well, the course was about ambient intelligence, which with a few sentences was a course about the elements of pervasive computing. So what elements? The machine learning, sensors, low power communication protocols, and embedded devices, with the aims to allow humans to interact with the environment in a natural way. Well, if we think about it, well, the smart assistants are a kind of thing where we are trying to do with pervasive computing. Or so the voice can be a natural way to interact with the device. Or in other contexts, the user habits, for instance, turning on and off the lights, simply because the environment knows our behaviors. But I don't want to talk about ambient intelligence in this context. Why I like to use this example to explaining why it wasn't the TinyML era yet. Because there are still the two ingredients, machine learning and embedded devices. But it wasn't TinyML era yet, because it wasn't that easy to develop machine learning applications on microcontrollers. You had to be an expert on machine learning. You had to be, or to have a good understanding of embedded system, because it wasn't also that easy to program a microcontroller at the time. So that is the reason it wasn't TinyML. But now, well, now is totally different. On the machine learning side of things, we have more sophisticated neural networks architectures. Furthermore, compared to 2013, for instance, we have more deep learning frameworks, free and open source and really easy to use. And also, if you are not a machine learning expert, don't worry, there are also end-to-end tools that can make the machine learning design straightforward and extremely easy. And sometimes the end-to-end tools can help you to learn how to design these machine learning models. So it's definitely something that changed a lot compared to already 2013. But what about microcontrollers? Well, also microcontrollers saw a transformation. So now are really easy to be programmed, and they offer a plug and play experience. I mean, in some cases, we have an IDE which is in the cloud, so which is web browser based. You just need to take your microcontroller, attach the laptop with a USB cable. With few lines of code, you can turn on and off the LEDs on the board. And it's not just like that. I mean, the same code most of the time can be reused on different platforms, because the IDE can cross-compile the application for you. So these definitely change a lot. But this is not the only thing, because now we have also much more low-cost sensors and microcontroller boards to experiment or build products built. So this is what we have seen in these years, and that is the reason why we are talking about TinyML now, because TinyML, or machine learning microcontrollers for this particular case, is for everyone. And the motivation for this book is this. The book wants to demonstrate how TinyML is for everyone now. Okay, so in particular for those with little familiarity or no embedded programming experience. Well, I believe from the motivation, probably you can also understand who is the target audience, who are the target audience. Well, machine learning developers, which are interested in developing machine learning applications or microcontrollers through practical examples. But of course, it's not just for machine learning developers, because if you are an embedded developer with a basic understanding for machine learning, a basic machine learning background, you can benefit from this book as well. So now that we know the motivation about the book, I'd like to jump to the book structure. So how the book has been structured to help people enter in the world of TinyML. So the book is a learning journey made of 8 chapters. So there are 8 chapters in the book with different, where each chapter is also a little more challenging than the later. But if you pay attention to this slide, there are also different colors on the right-hand side for the chapter. Well, because the first chapter is not really practical, it's theoretical, and it wants to introduce the TinyML principles. It's not just about explaining what TinyML is, but explaining what you need to know from the embedded world to become a TinyML developer. For instance, understanding the difference between energy and power and how these the use cases influence the design of microcontrollers. In the second stop, chapter number 2, well, it's not a TinyML project yet, simply because, well, in chapter 1, we have introduced the elements of embedded programming. In chapter 2, we want to make some practicing. So we want to learn how to build some simple circuits to be familiar with the concept of embedded programming. And after that, we have the orange chapters, which are the TinyML projects. TinyML projects, which are made of recipes. So the project will have a collection of recipes that describes what to build or program for that chapter. So the project have been chosen in particular because I wanted to ensure as less repetition of the recipes between the chapters. And in particular, because these recipes can be applied in different contexts and different projects as well. The other reason is because I wanted to show how to deal with various TinyML development challenges. These challenges can be from a machine learning point of view or can be from an embedded programming point of view. For instance, you can find recipes for training or design a model. You can find recipes for creating a multi-threading programming, or you can find recipes for building electronic circuits and so on. So it's a mixture. It's actually a TinyML book for this reason, because you can find the machine learning recipes, the embedded programming recipes, and the and so on. So concerning the recipe structure, so the book use a consist format for the recipes, and each recipe starts with an introduction, so to the problem. So in particular, the recipe, the introduction explain what you will build or program in that specific recipe. After that, it will follow the getting ready section. In the getting ready section, you will be prepared, or in short, you will know what you need to know for implementing the recipe. So actually, the getting ready section will help the reader to know exactly what is needed and why the things are needed for building that recipe. After that, we will follow the how to do it section, where the reader will do the things explaining the getting ready section. And in the end, some recipes will also have the there is more section in case the reader wants more information about the recipe. So what development platforms do we use in the book? So there are two microcontroller boards for showing two different development scenarios. These boards are the Arduino Nano 33BLE Sense board, and the other one is the Raspberry Pi Pico board. And what are these different development scenarios? So the first, with Arduino, is a platform which has almost everything. You have the microcontroller, you have all the sensors on board, and most of the time, you don't need to attach any components, of course, if you have the sensors for your application. So you take your microcontroller board, and you can deploy your TAN application without expanding let's say, the electronic circuit. On the other hand, Raspberry Pi Pico has a powerful microcontroller, but it doesn't have any sensors on board. So what can we do to develop a TinyML applications there? So with this platform, the book will present how to, for instance, expand the board with the sensors, with a temperature humidity sensor, for example, and in order to create TinyML applications also in this case. In terms of software tools for the TinyML development, well, the book will use different and diverse software tools for covering the machine learning, development, and embedded programming. But the book is just a snapshot of what you can find now in the TinyML ecosystem. There are other tools, our powerful tools, and this is just a snapshot of what you really can find there. I need to thank Arduino, Edge Impulse, and Google, because the tools presented in the book are actually cloud, browser-based, and with a free plan of usage, which means that most of the time you don't need to install anything. You just need to open your browser, just need to sign up, and that's it. You can start programming, you can start developing your TAN application, which means let's hustle to step out our TinyML application, which is definitely a good point. So, of course, the book is a learning journey, but learning doesn't stop there. So we also have a GitHub. So on GitHub, there is a source code and supporting material for the book. The source code is with MIT license. So if you want, you can copy and paste and use in your products as well. So the GitHub has different folders for each chapter, and you can find the source code also in the book with the proper link to each one. And also we have a Discord community that will be open the 1st of April. And there you can join other embedded developers to continue the conversation about TinyML, because the conversation does not stop there. The conversation must be shared to share our challenges, share also other problems that may be also resolved by other people, and improve and increase the knowledge sharing between all of us. So it's definitely great to have these two resources to definitely have a better learning experience. So what you will learn with this book. So this is a practical examples, that are different examples to learn different things. First of all, well, since the book assumes that you do not have an embedded programming background, from the book, you will learn how the relevant microcontroller programming basics for TinyML. And that is definitely needed because, well, if you don't have this background and you want to enter the TinyML world, well, either you buy a book for embedded programming, or, but the question is, what do we need to know for TinyML? And so the book tries to summarize only the things required to know from the embedded programming background. But there is also, the book will also be an opportunity to learn how to use real-world sensors data. So the reader will use the microphone, the camera, or the accelerometer to build projects around them. For example, the microphone will be used for voice recognition, or the camera for recognizing indoor environments, and so on. So the reader will interface with these sensors for acquiring the data and also to build and deploy these TinyML applications. Well, definitely, this is the other thing you will learn: run machine learning on microcontrollers. This is the goal, the key goal of the book. So wants to teach how to run ML on microcontrollers, but not just using a single software, for instance, TensorFlow Lite for microcontrollers, but also using other tools or other frameworks. For example, the reader will also use Edge Impulse for running machine learning on microcontrollers, or MicroTVM at the end of the book. Applications. So the reader will also learn how to implement an application that responds to the voice or gestures. The gestures in particular I really enjoyed because the reader will develop a smart remote. So with a hand will control a YouTube playback on your laptop. So we'll be able to change the music or video simply with your gestures at the end of that chapter. So it's going to be, I really enjoy writing that chapter. Leverage transfer learning to classify indoor environments. That is the other thing we'll learn, because transfer learning is an important technique, especially when you don't have a big data set to play with. It can simplify the classification problems, and this can also apply in the context of TinyML. And here there will be an interesting chapter showing how to do it using the MobileNet network as a pre-trained model. This is another thing I really like and enjoy writing, because it touches the area I'm working on at time, performance, in order to squeeze everything in order to fit a machine learning model, but also squeeze the computational capability. So to get the best in terms of computational capabilities from the platform. And here, the book will present some techniques to design a CIFAR10 model for a microcontroller, a virtual microcontroller in particular, with only 64 kilobytes of RAM. So in this chapter number 6 in particular, will be presented some techniques for designing a tiny model, and also showing how to estimate the memory usage before the deployment on the device. So it's going to be really an interesting chapter for those interested on understanding what are the basics for designing tiny mesh learning models for microcontrollers. And this is actually what you will learn at the end, because the book will end with something that is happening, is evolving, is still under heavy development, but we will have dedicated IEPs or processor for machine learning workloads. And the last chapter of the book will help to run an image classifier on an ARM virtual ARM Ethos U micro MPU with micro TVM. So the reader will touch two technologies which are growing: micro TVM, which is a deep learning technology, and micro MPU, which is a dedicated processor for running machine learning workloads on microcontrollers in a very power efficient way. So this is in general terms, but let's go more deeper. So let's talk about the chapters in terms of what you will learn and what you will do in each chapter. So chapter 1 is getting started with TinyML. So as I mentioned earlier, is a chapter that wants to introduce the TinyML principles. So in particular, the reader will learn the concept and terminologies of machine learning and embedded programming required for TinyML. Here, there will be a section dedicated, for instance, also to energy and power, to explain why these terms differ and what are the relation in practical terms. But also there will be a section explaining why microcontrollers exist and why have been designed in this manner. Why I decided to provide this section, to explain better what kind of use cases we may have in a TinyML, in the TinyML world. So this will, because microcontrollers have been influenced in design by the use cases. And so that is the reason I introduced this section in a chapter 1. What you will do in practical terms, well, just preparing the Arduino development environment. So in this section, you will prepare the Arduino web editor and run a very simple application as an hello world to say, well, now we are ready and we can do whatever we want with TinyML. Chapter 2 is prototype with microcontrollers. Well, it's still not a TinyML project yet. But here you will learn, so if you don't have an embedded programming background, here we will learn the relevant microcontroller programming basics. For instance, you will learn how to use the breadboard, the GPIOs, LEDs, and push buttons, create very simple electronic circuits. Why you will need to learn these? Well, if you prototype and machine learning models on your laptop, I'm really sure you are gonna use the keyboard and your monitor. Well, on a microcontroller, it's not exactly the same, where you will need a push button, which is our input for the microcontroller, and some LEDs to return the output in somehow. But also there will be an interesting section where you will learn how to power microcontroller boards with battery. And estimating also the battery life, so for your TinyML applications. What you will do, as I said, building electronic circuits on the breadboard and programming the GPIO peripheral in input, output, and interrupts mode through the ARM Mbed OS. Chapter 3. For chapter 3, we will have a separate section in this talk because this will be our practical session later on, also with Neuton.AI. So chapter 3 is building a weather station with TensorFlow Lite for microcontrollers. Well, the chapter number 3 wants to focus just the snow, just a simple snow. But the aim of this chapter is to learn all the development stages of a TensorFlow based application for microcontrollers. The other thing the reader will learn is how to acquire temperature and humidity sensors from the Arduino onboard sensors, but also an external one connected to the Raspberry Pi Pico. What you will do, you will collect historical weather data. That was, trust me, the most difficult part, finding a resource for collecting historical weather data for forecasting the snow, building the data set, design and train a machine learning model, building an electronic circuit with the DHT2022 sensor with Raspberry Pi Pico. Why this? Remember, Arduino Nano 33BLE Sense has a temperature humidity sensor, but not a Raspberry Pi Pico. So we will need to expand the Raspberry Pi Pico with this sensor to implement our weather station. And in the end, we will deploy the model on both platforms. So chapter 4, it will be a voice controlling LEDs with edge impulse. This is an interesting scenario. So also, honestly, in case we want to develop a smart toy to learn words, right? Because the aim of this project is to recognize words, numbers in particular, and colors. And here the reader will learn how to develop this application end-to-end with edge impulse. This is a keyword spotting application. And you will get familiar with the audio data acquisition. You will get familiar with the ADC peripheral and the timers. What you will do, so we'll acquire the data from a smartphone and build a data set to recognize color and number words. In particular, we will have 6 classes: red, green, and blue, 1, 2, 3. Once we have prepared the data set, we will design, train, and tune the machine learning models with edge impulse. Well, directly in the web browser. This means that we not have to install anything for this space. We will use just a web browser for doing it. After that, we will build an electronic circuit with the microphone with Raspberry Pi Pico. As I said before, well, on Arduino, we have the microphone, but not with Raspberry Pi Pico. So we will need to show how to do it with a Raspberry Pi Pico board. And in the end, we will deploy the model on both platforms. So chapter 5 and chapter 6 are the ones I really enjoyed writing. So, and I'm going to explain a bit why. So in chapter 5, we will build an indoor scene classification just with the Arduino Nano. So with the Arduino Nano, we will connect a camera. So, and we will apply transfer learning with TensorFlow, and the reader will learn the best practices for using a camera model and how to develop an efficient image processing pipeline from a memory perspective. Well, TinyML is not just machine learning or microcontrollers, and some aspects can be underestimated and make the development a bit challenging, I would say. And this is the case. I really enjoyed because it was a difficult project from a memory perspective, but not because of the model. Actually, the model was okay. So we use a pre-trained model from a mobile pre-trained model. But the problem was actually from the camera to the input of the model, because, well, the camera frame had an image resolution and color format completely different. But I'm going to explain in a bit what it means with an image. So what you will do in chapter 5, we'll learn how you will take in pictures of indoor environments using the Arduino Nano 33BLE Sense board and the camera model. You will design and train a machine learning model for sure. And you will program the following image processing pipeline by fusing the operators. This is what I just mentioned. So in short, we will get the camera frame and we will prepare this pipeline in the most memory efficient way for the model input. Why I'm stressing in the most memory efficient way? Because if we are probably on a desktop environment or also on a smartphone, well, you can call 5 different functions and that's it. You don't need to care. You don't care about the memory most of the time. But in this particular scenario, we need to be careful because the camera frame is pretty big, and we need to be aware that the memory on board is not endless. So it has some limitation. So the trick here was to implement fusing in order to reduce the memory peak of that pipeline. And that is the reason I really enjoyed, because it was a bit challenge to fuse all the operators together, but it's something you can also apply in other projects as well, I'm pretty sure. Chapter 6. So chapter 6 is a gesture-based application for YouTube playback. Here, the reader will implement a smart remote to control with gestures the YouTube playback. As I said, with the gestures will play or stop a video, will mute, unmute the video or song, and so on. So the reader here will learn how to develop an end-to-end gesture recognition application with Edge Impulse, but this time with just a Raspberry Pi Pico. We will not use Arduino Nano. But we'll also learn how to use this serial peripheral with the ARM Embed OS. This serial peripheral mentioned in the reported here is one of the most used for interfacing with sensors. So the reader will know how to use it and how to read data from it. We will learn how to acquire accelerometer data from the sensor, and in the end, there will be also an interesting section to filter out redundant classification. So the reader will learn how to filter redundant classification results from the machine learning, and why it is. Because when you run machine learning on a stream of data, you need to run machine learning with a very small step at a time. What does it mean? It means that for several consecutive it means that consecutive classifications will be really similar, but you want just one. You don't want to have 5 different classification results. So we will introduce an algorithm to filter out and return just the one of interest. What you will do, we'll build a dataset with Edge Impulse with data forwarded. So we will use a Raspberry Pi Pico to transmit the data over serial, and we use Edge Impulse to collect the data and build the data set. We will design and train and testing the model in Edge Impulse directly in the web browser. We will implement a multi-threading application with ARM Embed OS for Raspberry Pi Pico. And why we will need a multi-threading application? We need because we will need to acquire the data and also run the model inference at the same time or concurrently. And so the reader here will learn how to do it using the ARM Embed OS API. In the end, we will build a gesture recognition application, and the classification result will be transmitted over serial. And we will use this information to build a touchless interface in Python that will control the YouTube playback at the end. Chapter 7, we are almost there. So in chapter 7, we are approaching a different problem here. Here we want to use a classification problem to teach some basic techniques to make the model really tiny for microcontrollers. So the goal here is this. So we have the CIFAR10 dataset, and we want to run a CIFAR10 image classification on a microcontroller with just 64 kilobytes of RAM. So the reader here will learn for sure how to run an application on a virtual platform using Zephyr OS. Because in this case, we will not use Arduino Nano and Raspberry Pi Pico. Here we'll also explain how to use a virtual platform to be familiar in case we want to deploy a TinyML application, but we don't have the boards. And also learn how to design, or some techniques to design, an image classification model for memory constrained devices. What you will do, you will design and train a tiny CIFAR10 model for a microcontroller with just 256 kilobytes of program memory and 64 kilobytes of RAM. It's going to be pretty challenging, but pretty cool to deploy a CIFAR10 model here. And in the end, we deploy the image classification application with Zephyr OS. So we will complete we will finalize the application using the Zephyr OS. Chapter 8. Chapter 8 is the end of the TinyML journey, of the TinyML Cookbook journey. And here the project is on tools and frameworks that are still under heavy development, but probably will be the future of TinyML on microcontrollers. Here, the reader will learn what the ARM Ethos U55 microcompute is and how to perform the inference on a on a virtual platform. But also the reader will learn how to use TVM and micro TVM, which is a deep learning technology, which will use the TensorFlow Lite model as an input and compile the model in C code. So we will play with technologies that will probably happening in the near future. What you will do, we'll compile a CIFAR10 model with TVM and micro TVM, and you will build and run an image classification, in particular the CIFAR10 built in chapter 7 for the virtual Armitos U55 micro MPU on a Corestone 300 FVP. So we have finished with the overview of the chapters, but before showing the practical session and before showing also the chapter structure in the ebook, I consider some questions in the QA session. So does it make sense to answer now?
Yeah, let's answer some of the questions now, and then we will look at the practical session.
Yeah.
One of the questions was from Raj. Can you give a sneak peek into the behind the scenes of the book, which I think this whole session has been, so hopefully that question's been answered. Yeah. Are there any specific challenges that gave you nightmares? Which part of the book still keeps you stoked even now? And then are there any surprises for the reader?
Okay, surprises, hopefully nice surprises or bad surprises? Hopefully
I guess let's start with the first question. So were there any specific challenges that gave you nightmares?
Okay, yes, yes, there is. I believe the most challenging aspect was the dataset creation, probably for chapter number 3, because, well, is a weather station, you need historical weather data. The big problem is, where do I get the historical weather data from? Well, there's different resources, but most of them are not cannot really be used for commercial reasons, like a book. And the resource that I use in the book is actually one of the few that I could use for showing this use case. And that was, I believe, a big challenge. So finding a suitable, because I wanted to show exactly to build this weather station, but finding the correct data set, it was pretty challenging. Another challenge I found was definitely chapter 5 with the pipeline I mentioned earlier, fusing the operators, because there you need to be you are very close to the peak RAM usage. So, and the technique I mentioned earlier, I really hope it can be beneficial to other people, because I found it that was the only way to make it working, in short. So it showed you had to fuse all the operators together, which wasn't that easy in some cases, especially from the color conversion from the YUV to RGB, because you have to fuse after that. But it was challenging, but at the end, when I finished writing it, I was super happy, because I said, well, I really hope that the challenge I face and hopefully solve can be beneficial to other people.
Awesome. Another question, when will the training process or auto-tuning or adapting a model be available on board an MCU?
Oh, that's a big question. So there are already some technologies. Federated learning is one of these. So it depends what we mean for learning on MCU, on a microcontroller. So for training on a microcontroller, well, probably is not going to be the same on a server, but probably it will happen that we will have a future where we will need a training to fine-tune the machine learning model to behave or to be more, let's say, accurate to the human needs. Ambient intelligence is a good example, because you need a machine learning on microcontrollers. The application must respond in a natural way with the environment. But of course, it depends on the user. With a voice, for instance, right? You build your voice recognition, but my voice is different from yours voice, and maybe you need to fine-tune the voice. What is actually concerning me right now is the fact the fact that you need to train with int8 in particular, because yes, you may have a floating point, but floating point most of the time is more expensive in power consumption. So yes, you may train it, but at the same time you may you may consume too much energy from the device, and basically your device may that is the big challenge I see right now.
Sure.
Yeah, go ahead.
And then follow up from Raj, who's the intended target audience for the book?
Yeah, so the target audience are the machine learning developers, in particular, interested in learning how to enter the TinyML world, so run machine learning on microcontrollers. However, also embedded developers with with a basic and machine learning background can benefit definitely from this book.
Sure. I guess we'll spend about 3 to 5 more minutes on questions, and then any of the ones that we didn't get to, we can follow up. We have a Slack channel that everyone can join, and we can finish answer the questions. So let's just do a couple more. Have you read the book by TinyML book by Pete Warden and Daniel Lake? And if so, was it additional inspiration to write your book?
It's here. I was already in touch with Dan as well. So yes, it was, and it's complementary to that book. That book was about TensorFlow Live for microcontrollers in particular on different platforms. This is not just about TensorFlow Live for microcontrollers. It is also about Edge Impulse, for instance, TVM, micro TVM, and it uses also Raspberry Pi Pico not used there. And it's complementary because it has more embedded recipes than the other one. So definitely are complementary, these two books. I already talked also to Dan, who they wrote an excellent book as well. Not as well.
Awesome.
They wrote an excellent book.
Great. And then does your book cover or mention applications with 1D CNN for accelerometer signals, for example?
Yes. So the network used in that case was one-dimensional convolutional neural network in particular, but actually not that one. That one was mainly with fully connected layers, I need to be honest. So it wasn't with 1D, because the goal of that project was also to show an old approach for using machine learning, which was about the feature extraction. Well, feature extraction, we don't talk about feature extraction anymore in most of the cases, but it can be beneficial in some cases to reduce the complexity of the problem and make the machine learning application efficient from a computational perspective. So using the accelerometer in particular case, there will be the fast Fourier transform, the transformation to the frequency domain, and use a very tiny model with fully connected layers, actually no 1D convolutional neural networks, to solve the classification problem.
Sure. And then do the used microcontrollers used in the examples have optimized instructions for machine learning, or like preferential paths hardware-wise, ML cores that enhances the speed of the neural network?
Okay, interesting question. So the machine learning operations executed on microcontrollers on these two platforms are optimized for the CPUs, which are ARM Cortex-M based CPUs. In particular, under the hood is using CMC-CNN, which is a library developed by ARM, which provides the optimized routines for machine learning. The whole computation is on CPU using this library, except the last chapter, which is about micro-NPU. In that case, the execution is done on a virtual NPU. The Cortex-M CPU instead is used just to know when the computation on the micro-NPU is finished. So basically, micro-NPU triggers an interrupt, and the Cortex-M basically knows when the computation is finished to read the output.
Sure. And then I guess there's two last ones I think we could wrap up quickly with. Can we do the same chapter 5 with the Raspberry Pi Pico?
Oh, interesting. Yes, I love to have a one for Raspberry Pi Pico. So maybe in the next one, maybe. So unfortunately, that was one of the challenge that I faced, another challenge. So I had to decide, I couldn't really reuse what I had for one platform and reuse for the other. That is the reason I said, well, this chapter is going to be just Arduino Nano, and the following chapter, chapter 6, is just for Raspberry Pi Pico. But definitely I'd like to have it. However, the techniques used in that chapter can be applied in for Raspberry Pi Pico, so I'm not specific for Arduino Nano.
Cool. And then last one, how portable are the recipes detailed in the book with other microcontrollers, such as ESP32 microcontroller? Okay,
in most of the cases, we are talking about C code. Well, definitely, in some cases, not really, but it's more portable to, I would say, I haven't tried it, I need to be honest, but most of the recipes should be also can be also used in that context. I haven't tried, so that is the reason I'm saying, well, it should work, but I haven't tried.
And then how about the Arduino RP 2040?
And I haven't tried it, but it should work. This is the it's really similar to the Raspberry Pi Pico. It has the same microcontroller, so it should be it should work. I haven't tried it, but it should work.
Sure. And then at the end of your session, before we move to my session as well as Massimo's, if you can provide the Discord link or the couple of links that you had in the presentation, there were some requests there.
Yeah, absolutely.
Cool.
I can.
Yeah, I guess let's move on to the practical session. Raj will answer your question via typing.
Okay, that's perfect. So thanks a lot for the questions, by the way, quite a lot. I'm super happy to have for the questions. So let me go to, can you see my screen, right? Yes.
Yep, we're still good. Great.
That's perfect. So I'm showing chapter 3. This is a practical session. I'm not going to explain, show everything. Here is more about how this chapter is structured, where you can find the source code and what you expect to do with this chapter. So, well, actually, I changed to earlier because I wanted to explain what you are going to do in this chapter first. So this is the first chapter to show how the TensorFlow based application can be deployed on a microcontroller. So in the chapter, you will face the data acquisition problem. As I mentioned earlier, you will use a service to access the historical web data. Since we need to forecast the snow, I suggested a place in the north of Italy that I know it snows regularly between the end of November, let's say, and April. Once you have the data acquisition, you have all the data, historical weather data, you will prepare the training and validation data set. This will be a balanced data set to train our model. After that, we will design the model with TensorFlow. We will train with TensorFlow and we'll get the model. We will quantize the model because the model we have from TensorFlow is actually in floating point, but is not enough for our memory constrained devices, which most of the time only have integer arithmetics. Once we have the quantized model, we will convert to a C-byte array, simply because we will have a new file, tflight, which is not suitable for microcontrollers because we cannot read. We don't have most of the time an operating system for reading an external file. Furthermore, if you have an external file, this is totally inefficient because we cannot really store the model in program memory. And this is explained in chapter 3 and also in other chapters. We have with the conversion, once we have the conversion, we have the application development on the microcontroller. So in terms of chapter number 3, we have an introduction to the problem explaining what you should do in this chapter, what you're going to do in this chapter, and explain also the aim of the chapter at the end. So the goal of this chapter is to guide you through all the development stages of this TensorFlow-based application for microcontrollers. After that, you will have all the sections present, all the recipes actually presented in the chapter. For instance, you will import the weather data from World Weather Online, which is the service you will use to fetch the historical weather data. You will prepare the data set and all the steps presented earlier. Here, we will have two different scenarios, one for Arduino Nano and one for the Raspberry Pi Pico, because on Arduino Nano, we have the temperature and humidity sensor, but not on Raspberry Pi Pico, where we show how to prepare the input features for the model inference and run the inference with TensorFlow Lite for microcontrollers. You will find for each chapter the technical requirements you need in order to know exactly what to buy or what to have for completing the project. You will have the source code and additional material link. So you just need to click here. You jump straight to chapter number 3 folder, where you can find subfolders for the Arduino sketches and the Colab notebook. Let me go back to the ebook. So if I consider, for instance, the importing weather data, which is the first recipe, you have an introduction, as I mentioned earlier. And after that, you also have the link to get the source code for doing this recipe. So you can click here. It will open the notebook for Colab, and I should already have the Colab open. So this is the Colab open. So I imported previously. I imported the source code here, and where you can find the recipe, the title of the recipe, and you just need to follow the instructions reported here. So the Colab file is actually, you usually should find one Colab file for the entire project, but in the Colab file you have different names, that matches exactly the recipe in that chapter in order to discover the steps presented in the book. In this particular case, in this recipe, there will be the instructions. I'm gonna skip it because otherwise it takes some time to fetch the data online. So I already provided. You follow the instructions to fetch the data, and once you have the data, you can go to the next recipe, which is the preparing the dataset recipe. So if you want, maybe we can run something to see. So we import the Python libraries required, the constants required for this project. I'm gonna skip this because otherwise it takes some time. I already have a CSV file with all the data that I need. I just need to run this. This is just a simple change to read from the CSV file rather than from the data fetched. We prepare the data set. So before preparing data set, we visualize the snow. So in particular here, we want to recognize, I didn't mention this, I should have done before, but in short, we want to use the last 3 hours temperature humidity values to forecast the snow. So in short, if it snows or not, whether it snows or not. So this chart will help us to understand more or less when it snows. And as we can imagine, when the humidity is pretty high and the temperature is pretty low, well, there is a good chance of snow. And let's go back. Let's go on. So there is the generation of the labels, because the output provided by the World Weather Online is actually not yes is no or it doesn't. Is actually the snowfall in centimeter. So and in this particular example, we consider the snow when the snow is above, for instance, 0.5 centimeter. So for this reason, since we have a classification problem, which is a binary classification problem, we have to label it. We have to label it with this, with yes or no. Yes, it is no. Yes, it snows or it doesn't. And you build the data set. Once you have built the data set, there is a big problem. So as I said before, in Kanazai, the place I consider for this project, it snows regularly between the end of November and April. But this means that we should expect more days of no snows, so which means the dataset is unbalanced because you have more samples with no snows, which is not ideal if you train a model. And in this particular recipe, there is the section where we show how to balance the dataset. That was the percentage of samples for the no-snow class, which was 87%. What does it mean? It means that if the machine learning model does not classify this class, well, you can have 87% of accuracy, but actually the model doesn't work. So for this reason, you have to balance the data set, to have 50% split. So after that, there is a normalization stage or the scaling stage, because the input features have different different ranges. The temperature can be, for instance, negative. The humidity not, it can be just positive, and between 0 and 100. The temperature instead can be definitely with a different range and negative. So you need to scale the features in order to have a common range between them and have a better accuracy results for your model. Once you normalize, you need to consider that you normalize it, and you need the minimum standard deviation you use for the normalization applied here, because this will be necessary when doing the model inference for applying the same normalization technique that you use for training. Well, there is a visualization of the distribution of the samples here, showing how it changes the x-axis after normalization. As you can see here, more or less in both cases, the center is 0 with an interval which is definitely similar between -2 and 2. So it's definitely the two if input features have same range. You create a data set. You definitely you basically prepare the data set for training. So you extract the input features, you encode the labels, because yes, we assign yes, it's no, and no, it doesn't, but it's not. So we need also to assign a number in order to train properly. So we need to encode the label in order to make it working. So we transform the yes and no to 0 and 1 actually, in order to train our binary model. We have the split data set, train, validation, and test data set, and so on, all the steps that you may find in a classic machine learning problem. At the end, when you have your model prepared, you will have the section where you need to convert the machine learning model to a C-byte array that you will simply, if I can move, you can move to the Arduino web editor, and that's it. The thing I wanted to show in particular is the fact that most of the tools used in this book are browser based, so you will need to install anything. You just need to drop copy and paste things between the tools, and it will be ready, the TinyML application. I don't know if you wanna proceed with this, because I wanted just to give an overview of what the reader will find. But of course, Andrew, I don't know if you wanna talk about Neuton.AI solution now, or you wanna, there are questions related to what I've just shown.
There weren't questions, but if you could just wrap up in 1 or 2 minutes, and then we can move on to our session, and then leave some time for Massimo as well.
That's perfect. So definitely, in this particular case, there are just two. With just 2 tabs on the web browser, we will be able to design and train the model. On the other hand, we have Arduino web editor, which is the reference IDs using in the book, where you will need just to connect your microcontroller, will be detected, and you will be able to deploy your machine learning applications quite easily. So all the steps are presented in the book. So, and hopefully should be straightforward to reproduce the results presented there.
Perfect. Awesome.
Yeah.
No, yeah, this has been really great. I mean, we've learned so much. With this, you've enabled a lot of people to do a lot of experiments and everything like that. So thank you so much for walking us through that. Next up, for some of you who aren't familiar with Neuton, I'll give a quick overview, and then we'll look to see how to take the data set that Gian Marco just showed, and then quickly and easily build a model with Neuton. So yeah, if you could close your screen share, that would be awesome. Okay. Awesome. For those of you who aren't familiar with Neuton, we really strive to help make your edge devices intelligent. So we will help you automatically build extremely tiny and explainable models without any need for coding or machine learning background, and embed them into any microcontroller. And with Neuton, we can really empower users to build these models with very small size and without the loss of accuracy. And we can do this automatically. We can do it in one iteration, and there's no need for compression or quantization or some of the other techniques that may need to be used. So as we saw from the example of Gian Marco, here's kind of the overall steps in order to do it with the TensorFlow solution and TensorFlow Lite. When we leverage Neuton, we can simplify the process, and so can automate the creation of the neural network. We do automatic cross-validation. We can create this model in one iteration. In fact, create a model quite a bit smaller than the TensorFlow model, and there's no post-training quantization needed. And the solutions are all out of the box ready to go for 8, 16, and 32-bit as well. So let's take a look and see a Neuton in action of how we would want to create the model leveraging our platform. Awesome. So this is the Neuton platform. So as we kind of saw earlier, a lot of movement towards web-based browser. So everything you can leverage on the browser. And you can see here I have a lot of different solutions that I've built. So they're all tile-based. And in order to create a model, we simply will add and create a new solution. So this will be snow prediction. So this will be for the TinyML Cookbook use case. So there are 3 steps that are needed: uploading your data set, training your model, and then doing predictions. So right now what I'm going to do is upload a data set. So here I have 3 different data sets. The training set, which is 85% of the data set, and then validation data set, which is 7.5, and then some data for testing. So here I'm going to upload the trained data set. Right now, we've uploaded it. I'll just take a quick look at the data set here. So we've got temperature and humidity, as we saw earlier, and then the target variable, which is not snow, or 0 for not snow, and then 1 for snow. So that's kind of a snapshot of what the data set looks like. Once you've done that, you will then want to go into advanced mode to add your validation data set. So we're doing it in the same way that Gian Marco did. Here I've got my validation data set. I already have the file because I did it preemptively so that we can take a look at the model once it's completed. Here, all we need to do is select the target variable. Here, we have our target metric of accuracy. Now we're going to enable tiny machine learning. As I had mentioned, you can select your bit depth, but in this case, we'll use 8, and we can leave that. So now the Neuton model is being automatically trained in the backend on Google Cloud Platform. You can set up mobile notifications so that it'll let you know when the training is complete. This will take a few minutes. So I've pre-trained a solution for demo purposes. So let's take a look here. So this took 24 minutes to train. We were able to get an accuracy of 88%. And once the model is created, we have 3 different options. We can download the model for embedding, and we'll provide all the necessary C code that you'll need. Additionally, if you're interested in explainability or looking at individual predictions under the web prediction tab, we're able to use what we call our model interpreter to look at the individual predictions. So I've already uploaded the data set that we need to create predictions. So Neuton has created predictions. Let me just show that step real quick. So what you'll want to do in order to create predictions is upload that data set. So here is our test data set. So this data set is all of the different features that we saw: temperature, humidity, etc. And then, but without the target variable. So we can take a look at our predictions now. Here we have all the predictions that the model has created. In this particular instance, we saw that we did predict snow, but with a probability of 57%. So this might be an interesting one to try to understand. Here we can look at the different variables that are influencing the predictions, and we can actually see if we adjust them, if it will change the result from snow to not snow. So that's just a quick overview of the platform on how to create an AI model. And just to wrap up, and then to pass over to Massimo, I just wanted to highlight a couple of things. Here are some of the results that we saw between Neuton and TensorFlow Lite. So we're able to make a model a little bit smaller. As you kind of saw, it was pretty easy. Upload your data, do a couple of clicks, and then your model is created. And we've seen the models that we can create are to 1,000 times smaller than some of the traditional approaches. Here's just a few more interesting kind of benchmarks we've done with various different use cases. And also Neuton works well with 8, 16, and 32-bit microcontrollers, as mentioned before. So we do have a unique framework to help build these models automatically, make them very small, and you don't need the data science background as well. We do have a completely unlimited and free plan for developers. So we encourage you to go and try it out and start your journey there. And all you need to do is go to the Neuton.AI start link to go from there. And just a couple of other things, we've also built some interesting models and deployed them on Arduino devices. One of which was handwriting recognition, so able to recognize what digit the user was writing in the air. So with that, Massimo, we're excited to have you. I know you've got a lot going on this week. So we appreciate you taking the time. So yeah, just as ways of introductions, everyone, Massimo is the co-founder of Arduino, and he is an interaction designer, educator, open source hardware pioneer, and also a TED speaker. He spent 4 years at the Interaction Design Institute, Ivrea, as an associate professor and worked as a consultant on projects for brands like Prada, Whirlpool, VA Museum, etc. And he is also the author of the book Getting Started with Arduino, published by O'Reilly. So Arduino, Massimo, welcome. Excited to have you. We'd love to hear a little bit about kind of what you guys are doing in the Arduino Pro family, and maybe some insights about the Arduino week and all that good stuff. So yeah, happy to have you.
Hi, and thank you for having me. Yeah, we just, like an hour ago, we just finished streaming an event because this week is Arduino week, because it's the birthday of Arduino. So we have this event. It used to be Arduino Day, and now it's Arduino week. So it's quite a lot of work. So we are
happy birthday.
Thank you. And every afternoon we stream for like 2 or 3 hours. And today was actually the day where we were streaming. We were discussing the pro products of Arduino. I mean, one of the things that happened in Arduino, as a lot of people know, it started off as a teaching platform. Then it became the platform of choice for makers. And then what happened is that more and more of these makers started to build things that ended up in companies, and companies started to use Arduino to build things. So they some of the 8-bit Arduinos that were designed for kind of, consumer use, let's call it like that, ended up in products, in machinery, and different things. So that's when we started to work specifically to create a group inside the company that kind of helps companies implement solutions that are based on Arduino. So today we presented some new stuff. Well, I think it's the biggest news that we presented today. We launched this thing called the Portenta X8, which is a fairly small board, which has an IMX8 multi-core Linux machine on it, and a multi-core STM32 microcontroller with Wi-Fi, Bluetooth, a bunch of other things, which is compatible with this Portenta family that we have. And I think it's the first time that we do a Linux machine in many, many, many years. And I guess the main thing for us is that it's designed to be something that you plug in and it just works. And it's got this system on the software side where you can deploy containers. So you can run, models developed with, with Neuton on the microcontrollers, or you can run it on the Linux machine, depending on the kind of application. But I guess, yeah, some of the stuff that we're doing right now is designed for robust industrial use cases. I know you guys built a project with the Nikola Sense, which is a tiny postage stamp sized board, which has a bunch of very professional Bosch sensors, and then a Cortex M4 microcontroller with Bluetooth connectivity. And I think that is doing quite well as a sort of sensor platform. It even has this strange, powerful sensor from Bosch that can be trained to understand the gases that are in the atmosphere. So you can, there's an article from Bosch showing how you can detect coffee with it. So yeah, it's I think more and more of the stuff that we are doing right now is building these building blocks that are used by people in the industry, by people in agriculture, by people who are trying to kind of build sophisticated projects. And we're trying to support as much as possible TinyML use cases. So, you know, our tools tend to be supported by your platform. So it's pretty good.
Totally, yeah. One of the developers that leveraged our platform, they created a use case on Hackster for detecting food spoilage, which was really cool. And there's lots of applications for that, right? If maybe you could tell us a little bit about the Arduino ecosystem, the community, and maybe how people can get started.
Yeah, so the community is, depending on where you set the bar, the numbers can be really big. So if we can start by saying that about 39 million people visit the website every year, unique users. So there's like quite a lot of people who are generally interested. They start to, you know, they heard about Arduino and how sort of it's a tool that makes it easy for people to get started with electronics, because it's designed for people that don't have a background in electronics. And so there's we created these development environments that people use to program. Gian Marco was showing the one that we have in the cloud, which is very popular for example, in schools, because you don't have to install anything. It runs on Chromebooks. So it's kind of simple, and you have all your code in the cloud. So you don't have to, and funnily enough, there are some platforms in which the cloud IDE is faster than the local IDE. So on Windows, the compiler needs to kind of fight with the, I guess, with the operating system, while on the cloud, it just goes really fast. So we have these development tools that are downloaded about 30-something million times a year. So we were looking at the IDE is downloaded once every 0.7 seconds.
Wow.
So it's kind of a large download. And in a way, that's kind of the basic tool that allows you to program Arduinos. The classic Arduinos were 8-bit microcontrollers. Now the new ones are 32-bit ARM microcontrollers. So the way people start, it's normally either they are taught Arduino in school. It is actually quite popular for teaching people about electronics in different kind of schools. And we have a whole section of the company that just builds tools for schools. Actually, that team is right now in London, where there is this event called BET, which is like the biggest education event in Europe. They're presenting a few tools. Then other people buy a starter kit, which is a sort of a classic box that contains the classic Arduino Uno, which is the 8-bit platform, and a bunch of components and a book. So you go through 15 projects, and you learn all the basics. And then from there, you have several different kits. If you want, you can buy, but actually there's quite a lot of free content online. So it's kind of easy. And also Arduino tends to be available from all the distributors, online stores and everything. So I would say all of our latest efforts are more in the region of enabling IoT on one side and the tiny machine learning use cases, because we think it's very interesting. The tiny machine learning, in my opinion, has a number of interesting values attached to it. First of all, for certain application, it increases privacy, because the raw data never leaves the device. You process it locally. So people can make different use of the data, which is very important in some use cases. There's an aspect of sustainability because you're using, if you're using microcontroller, you're reducing a lot power consumption. And it's interesting because it's very useful in industrial uses. No? So you have a sensor, you attach the algorithm to the sensor. So there's the most efficient way to process that data is TinyML. So we are super interested in that. Also, I'm very happy that tools like the ones that you build are happening, because kind of they take away the, when I try to teach, I still teach, and when I try to teach my students about machine learning, it's a bit tricky, because so if you have a tool that you say, well, here's the data, press the button, here's the model, it's kind of magic, So it's, I appreciate actually the work that you guys are doing that enables almost anyone to really get results. And a lot of the people that we target as Arduino are small and medium companies where people want to use innovative technology, but they simply don't have the skills to go through the classic path to learn about machine learning. They can't hire people from universities. They just want to do things themselves.
Absolutely. Yeah, a lot of that resonates, of course, with our mission to help democratize machine learning, make it available and all of that good stuff. So Massimo and Gian Marco, thank you for joining us today. Just to kind of wrap things up, we will be opening up 30 free ebooks, and the results will be announced tomorrow. We did also provide a link to the Slack channel. If you can get in there, the announcement will be done there as well. And then also we encourage you to check out the Neuton platform, get in there and check out some of the use cases that we had mentioned as well. The food spoilage one is in there too, if you'd like to explore that as well. So just to wrap everything up, thank you everyone for joining. Thank you for the awesome participation.
Can you give me 1 minute to explain a little bit about giveaway, because I think we have a lot of questions about it.
Sure.
Yeah, cool. So again, thank you so much to everyone who was with us today. So let me just explain you how to get your free ebook and how to get all this amazing knowledge that Gian Marco presented to us. Let me just put it like here and explain you in few words. So we, as Andrew mentioned, by tomorrow in 1 day, we will upload results of this giveaway on our Slack channel and also on LinkedIn. In order to participate in this giveaway and get your free, absolutely free, amazing TinyML Cookbook, you just need to do just 2 steps. First of all, we need your registration on Zoom or LinkedIn just to have opportunity to get your email and write you that you are the luckiest one. So please check if you have a registration. And the second, we need your free subscription of Neuton.AI. So we would like you to try all the recipes that you will get from this ebook and try to build the same models on Neuton platform. So just do these steps, and all of you that will complete these 2 steps during today and also tomorrow will participate in our giveaway. So please, if you have some questions or some doubts how to do it, if you need some help, so please, I shared also here in chat the link to our Slack channel, where you can be in contact with me, with our technical support, and we will help you with these steps. And of course, please also join our Slack community. So you will see, I hope, your name in the list of the winners by tomorrow. And a part of this, of course, I would like to say that we have a lot of, records from previous amazing webinars, ebooks. You can share also your knowledge and ask community for any help. So please join. You are very, very welcome. And also join our LinkedIn to be aware about our next events that we are going to do. Actually, we are doing it like a once in a week or once in 2 weeks. So please join. And I think it's this. That's all. If I will share now in the chat the links to Slack channel as well, so you can join it. Maybe one only thing that I would like to share with you also. It's the possibility that you can not only, if you don't have your, let's say, data set, if you don't have any use case right now, but you would like to try and you would like to start, our platform also provides some very interesting use cases that you can play with. Let me just share my screen and show you where you can find it. So if you go to our platform and let me, do you see maybe here? Okay. If you go to our platform and go to use cases, so you will find a lot of case studies, and you can play with them and try to understand how is all pipeline looking for. And then, of course, you always have a possibility to play with your own data set. So again, it's if you put in any of the case, you will see the very simple guide, instructions, and each step you need. But anyway, if you need some more information, you always can contact us and ask our team to help you. So in Slack channel, we are like a 24/7 there. I think it's everything that I would like to share with you. And here in the chat, I will share also the links, the useful links for Slack channel and for our platform.
Awesome. Thank you, Yulia.
Okay, I think, yeah, okay. Yes, and LinkedIn, I see the questions. If you see us from LinkedIn, you will participate in our giveaway as well. No worries. Let me share this link for their Slack. Okay. Thank you. So once again, we are very happy to see you on our platform, on our Slack channel, in our YouTube channel. As I mentioned also in the chat, I think for someone who missed some parts, interesting parts from amazing presentations from Gian Marco, from Andrew, from Massimo, thank you so much. We will upload records of today's session on our YouTube, on our LinkedIn, and as well in the Slack channel. Okay. Thank you.
Cool. Thanks, everyone.
Yeah. Thank you, guys. Hope we see each other in the next session. Thank you so much, Massimo. Thank you so much, Gian Marco.
Really a pleasure.
We are absolutely sure that your book will be bestseller of this year.
So thanks a lot, honestly, for organizing this event and hosting the event. So it was great. I'm super happy. And thanks, Massimo, to join us.
You're welcome. Thanks.
Bye-bye.
Bye-bye. Thank you.